So what we're going to talk about today is the algebra of functions, and hopefully we'll be able to make some distance into lines. So we're talking about the algebra of functions. We're talking about adding functions, subtracting functions, multiplying functions, and dividing functions. So first off, let's consider this algebra of functions, and let's define a couple functions. Let's say, and here I'm going to erase the title here just so I can have more room. But let's say we have this. Let's say we have two functions, f of x and g of x. So we're going to define some notation. F plus g of x. This symbolizes f of x plus g of x. So for our example, f plus g of x we're just going to add the two functions, and in this case combine like terms. So 3x and 2x, those will add to 5x. 1 and -7 will be -6. And that's going to be our answer. So any questions about that? All right. So f of x minus g of x. So what this means is we just subtract the two functions. So f minus g of x. F of x is 3x plus 1. And then we're going to subtract the entire function of g of x. We'll distribute this minus sign. So you have 3x minus 2x. That's just x. And then 1 plus 7 is 8. Questions about that? So now we consider this. This means we multiply the functions. So for our example, we're going to FOIL. 3x times 2x, 6x squared, 3x times minus 7, or the outer. We've done the first, now we're doing the outer. We do the inner. And then finally, we do the last, 1 times minus 7, or we'll say minus 1 times 7. Or to be fair, we can be a little more consistent. Plus 1 times minus 7. A little more accurate. So again, we'll simplify a little more. 6x squared. We have 21x plus 2x minus 7. Minus 21x plus 2x is minus 19x minus 7. And that's going to be our answer. Questions about that? So the other one, f over g of x, excuse me. Well, this will be f of x divided by g of x. So this will be, for our example, and that's it. Now, questions about that. Also, how did you feel about FOIL? Was that something you were okay with? Kind of went a little fast with the FOIL. Let me show what I was getting at with that. So when you're multiplying functions together, there's a couple ways you can do this. First off, we can distribute this entire piece here. So when we distribute it, what we'll get? And so now what we do is we distribute this, and we're going to distribute this inside the parentheses. Don't forget to distribute the sign also. The sign's going to go with it. 6x squared plus 2x minus 21x minus 7. Now we combine like terms. 2 minus 21 is minus 19. And they have a minus 7. So that's one way you could multiply things. There's another way, it's a shortcut called FOIL. I'm going to go through a FOIL. So what FOIL stands for is first, outer, inner, and last. So this will be first, outer, inner, and last. So how do we do this? Well, first, what we mean is this. Multiply these two together. These are the first terms of each function. 3x times 2x is 6x squared. In fact, let me write it as a multiplication. Then the outer terms for everything, 3x and minus 7. So outer will be 3x times minus 7. It's a negative 7 there. I know it's a little small. And then inner are these inner ones. Finally, last terms of each function. So if I perform these multiplications, what we'll get? 6x squared, negative 21x, 2x, negative 7. Now I combine terms. 6x squared minus 19x, negative 21, positive 2, adds up to negative 19, minus 7. Questions about that? So that's how FOIL works, and you'll see it used a lot. Now, there's something else that comes up in this section. This is, I think, really neat. Domain. So domain is about the choice of inputs. Now, I've said before that the advantage with inputs is we can choose whatever we want. And so we say that's an independent choice. So the variable that represents that choice, which is usually x, that's an independent variable. Excuse me. Y, which we represent usually as the output, that depends upon what we used as an input. So we say y is the dependent variable. Now, the thing is, though, in all honesty, there are limits to what we can choose for inputs. And in this course, there's usually 3 things that limit us. Number 1, we don't want to use inputs that cause a division by 0. So we want to avoid division by 0. The other thing we want to avoid, square roots of negative numbers. Finally, some inputs we're told to use. We're instructed to use certain ones and not others. For example, time. Time is almost always considered positive, and we don't really use negative values for time. So sometimes the domain is defined for us. We can only use certain values depending on what our independent variable represents. So those are the usual. Now there's other things that come up later. For example, logarithms. There's limits to the variables we can use for or the values we can put inside logarithmic functions. There are some values we want to avoid for the tangent function. Values we want to avoid for inverse trigonometric functions. We're not going to be working with those in this course, but we will be trying to avoid division by zero. We'll try to avoid the square roots of negative numbers, technically the even roots of negative numbers, but that's another story. And then for some functions that are defined on time, where time is the input, sometimes we're going to insist that we start at time equals zero and just have positive numbers be future time. And we don't try to predict things in the past, though sometimes you do, but usually you don't. So this is the kind of problem you're going to get. So if we take a look at this, we want to look for essentially three things. Is there the possibility of a division by zero? Is there the possibility of the square root of a negative number? And are there any restrictions on the domain that we just need to follow? Well, there aren't any restrictions. It's fairly plain in what they're asking for, just find the domain. There are no square roots or even roots, so we don't have to worry about those. But there is a division. And the key thing here, what we're dividing cannot equal zero. So we need to make sure that we do not choose a value for x that causes this thing to be zero. We don't want to choose a value for x that causes 2x plus 3 to be equal to 0. So what value of x do we want to avoid? Well, let's solve for x to find out. Again, I'm doing opposites. Now, division is another term for a fraction. So we find that x, this becomes 0 when x is minus 3/2. So that's the thing we want to avoid. So there's different ways of expressing this in math. We could say avoid x equals negative 3/2. Usually in words, we would say this. X is all real numbers except -3/2. So we could put it into words like that. There's something else though. We want to give a symbolic answer. So let's take a look at our number line. So the number line would have a hole here. And so if we put in our hole, we can have all the numbers of the number line except -3/2. Now, what's everything to the left? Well, we keep going to negative infinity here. And this here means we come just short of -3/2. On the other side, we start just after -3/2. We don't include -3/2, and we keep going off into infinity. So this would be our answer. We're going to take this part of the number line and combine it with this part of the number line. It's like we're taking all the numbers from this part and all the numbers from this part and then just dumping them into a box and calling that our domain. There's one number that we're excluding though. We're excluding -3/2. So questions about that? Now in this section, the only thing you need to worry about are going to be divisions by 0. In other sections, we're going to have to watch out for square roots. But that's basically it, except for one last concept. So they should be giving you this one. I'm surprised that they're not. Look. Well, we'll probably review it again, but I want to show you this idea. It's called composition. So this FG in this little circle, this means we replace the x with f with the entire function g of x. So what this looks like for us is we're going to replace the x and f with g of x. So 3 times g of x instead of 3 times x. And we do our substitution. We'll distribute the 3. And that's going to be our result. Now, what happens if I go G circle F? What does that look like? Let me make sure you can see. Yeah, you can see. Well, this means G f of x. So this means we take the x that's in G and replace it with f of x. I distribute the two. So I get a different answer, which is actually perfectly fine. So F composition G does not always equal G composition F. So any questions about that? That's pretty much 2.3. I do want to do one other example though. Let's see. I want to do a tricky domain one. So let's say we have this. So let's say we want to find the domain. Of f plus g of x. Well, let's take a look at what f plus g of x looks like. Well, it's going to look something like this. Now, again, what we want to look for are places where we've got restrictions on the domains that we've been told to follow, and there aren't any on this one. Are there any square roots? No square roots. But we have two divisions. We have to be careful with dividing by this and dividing by that. We want to see where these are equal to 0, because that'll tell us what numbers to avoid. Well, if we add 2 to both sides, we get x is equal to 2, because 2 minus 2 would be 0. Subtract 3 from both sides, you get x is equal to minus 3. So these are the two numbers we want to avoid for x. So we want to represent now 3 intervals using interval notation. So for this one, it's minus infinity, but we come just short, excuse me, of -3. For this interval, we go from -3, or just ahead of it, to just short of 2. Now again, I'm using parentheses because we don't want to include these numbers. They're sort of doing their own thing. And then just above 2, we go to infinity. So we're going to take all the numbers in here, all the numbers here, all the numbers here, and just dump them into a box, and that's our domain. And the way we state that is with the union signs. Questions about that? So I just want to go over another question. It's just sort of a really notation thing, just to make sure. No, I think that's it. I think we're good. Oh no, here it is. Here's a notation one. So let's say we have this. So let's say we're asked to find this. So we'll just go with 4. -4. We'll stick with it. Well, again, this means divide. So what this is saying is, let's take a look at f over g of x. Well, that means we take the function x, we divide it by the function of g. Oh, take a step back. So that's f over g of x. Now we can do f over g of -4. -4 times -4 is +16. Double negatives becomes a positive. We'll get 32 over 8. I'm sorry. This becomes 2 plus 4. 32 over 6. And we can reduce that down to, excuse me, 16 over 3. And that's going to be our answer. Questions about that? So that's going to be 2.3. We go on the 2.4. So what's going to happen here? One thing real quick. So for 2.4, we're going to be getting to what's called linear functions. And basically what a linear function is, it's a function that describes a line. We see these presented in different ways. The most common way is y equals mx plus b. This is a form of a line. So let me do an example. So in this case, the input's going to be x, and the output's going to be y. We could write this in f of x format. We could say this. Either way is good. So let's get some inputs and outputs. So for -2, we'll get 2 times -2, which is -4. -4 plus 1 will be -3. 2 times -1 is -2. -2 plus 1 is -1. 2 times 0 is 0. Plus 1 is 1. 2 times 1 is 2. Plus 1 is 3. And then 2 times 2 is 4. Plus 1 is 5. So I'm just going to rewrite this so it's higher up. So we have x is -2, y is -3, so that'll be right about there. -1 and -1, right about there. 0 and 1, so here's 0, here's 1. 1 and 3, so here's 1, here's 3, so you're right about there. 2 and 5, there's 2, there's 5. And there. If we connect these dots, barring my questionable drawing skills, we actually, it looks a little bent, but it's actually supposed to be a straight line. And that's what these kinds of functions produce. They produce lines. So we're going to look at some versions of these things. So first off, we're going to talk about intercepts. So first off, we have what's called an x-intercept. I'm going to abbreviate it as xint. And it goes like this. It's where the line crosses the x-axis.